Hi, it's Dr. Prasad Puthiyillam. Continuing my classes on ion exchange chromatography. This is class number 3. In previous class, I explained about the basics of ion exchange chromatography, and this particular class it is for the principle of ion exchange chromatography. So, a schematic ion exchange column is presented here, which contains the resin. Okay, so here the resin, that spherical ball or sphere which I represent, that is a resin with R as the functional group present in that, and X minus is its counter ion. Okay, therefore this is the resin with a particular ion exchange capacity. So here it can exchange anions because the counter ion present here it is X minus. Therefore it can exchange with Y minus or any other anion. So it's schematically represented here. So if a solution containing Y minus, it is eluted through this column, then we can say that a mixture of Y minus and Z minus is eluted through this column, in which the resin R, actually R plus Rx minus it is represented here. I can, or I can say that it is R plus and X minus. It is selective to Y minus ions only. That means X minus ions, due to some interaction, it cannot, Z minus cannot interact with R plus, but Y minus can interact with R plus. Therefore, if it is allowed to pass through that, the Z minus ion, it will reach to the bottom of that column at a faster rate because it cannot interact with the resin, whereas the Y minus, it may replace that X minus, and it will sit along with the resin. That means from a mixture of Y minus and Z minus, if I say, the Z minus can be removed easily. uh, then getting that Y minus ion, we have to further add with the solvent molecule containing that X minus, then the Y minus also will be replaced with that. So this is the basic schematic representing how this ion exchange resins work. It will work for cation exchange resin as well as anion exchange resin, can be explained with that scheme itself. So that particular scheme presented here, that is for the anion exchange. Likewise, you can think about a cation exchange in a very crude way. Okay, so ion exchange chromatography, it separates molecules based on their respective charge groups. Ion exchange chromatography retains an allied molecule on column based on coulombic or ionic interactions. The ion exchange chromatography matrix consists of positively or negatively charged ion, and essentially the molecule undergo electrostatic interaction with opposite charges on the stationary phase matrix. The stationary phase consists of an immobile matrix that contains charged ionizable functional groups of ligands. So if ligands are there, usually chelating ligands are used for this particular application. To achieve ligand chelating, means chelating molecules are used as ligand. To achieve electroneutrality, these inert charges coupled with exchangeable counter ions in the solution, say ionizable molecules that are to be purified. The mixture of a compound which is to be purified, it will compete with the exchangeable counter ions for binding. Okay, which one they will they always have a competition to get binded to the resin surface, and the immobilized charges on the stationary phase. These ionizable molecules are retained or eluted based on their charge. Based on the potential or the amount of charge present in the counter ion, we can separate the molecule. Initially, molecules that do not bind or bind weakly to the stationary phase are eluted first. They will can be washed out first, and the altered conditions, variation of conditions, say example temperature also, but usually pH, we are much focused on that. The concentration of exchangeable counter ions which compete with the molecules for binding can be increased. We can either increase the concentration of the solution that we use at the separation of the mixture of ions. We can dilute it, we can add excess water or any solvent which you can use. Either we can increase the concentration, then also we can separate the ions easily, or we can change the pH conditions, that also will affect the binding capacity or charge on the molecules. charge on the atoms or molecules, whatever it may be. So additionally, concentration of counter ion can be gradually varied to separate ionized molecules. This type of elution is called gradient elution. Gradient is something related to the concentration. So if you vary the concentration, the varying the concentration and maintaining the condition, we can separate ions. That particular type of ion exchange chromatography is known as gradient elution type. Positively charged molecules bind to cation exchange resin, and negatively charged molecules will bind to anion exchange resin. So representation is given here. Reaction R minus represents the resin which is having a negative charge, and X plus is attached to that resin, and it is used to separate the Y plus, that is a cation exchange, a cation ion. So this particular resin used R minus, it is a anion, is a cation exchange resin. It can exchange or it can separate the mixture with cations. The further reaction, complete reaction is given here. Same way we can write it for anion exchange resin case. So R plus can be treated as an anion exchanger, and it will exchange with the X minus is exchanged with the Y minus. Therefore, that reaction is also given. So hope this is the principle behind ion exchange chromatography. Hope you understood the principle behind the ion exchange chromatography. The different chemical reactions given by the ion exchange resins, namely the strong acid cation exchange resin, weak acid cation exchange resin, strong base anion exchange resin, and weak base anion exchange resins. Those different type of reactions and the properties of ion exchange resins will be discussed in coming classes. Thank you very much for watching my video. Those who are not subscribed my video, please subscribe to my YouTube channel, and press the like button as well as uh, the bell button, so that you will get the notification as soon as I upload the videos. If you understood the concept, don't forget to like my video also. Thank you very much, and have a nice day.